But for right now, we've got Dolev Farhi, who's going to be doing Breaking the Habits, Continuous Security. And you can join and chat in the Discord, ask your questions, and I'll pose them on to Dolev. So Dolev, please take it away. Thank you.
Hey, what's going on, everybody? Thanks for joining and good morning. This talk is called Breaking the Habit with Continuous Security. So my name is Dolev. I'm currently the principal security engineer at Wealthsimple. And prior to that, I spent a few years with Paytm F5 and CyberArk. I'm also one of the founding members of DEF CON Toronto. I'm super excited to be here today. And we have a lot to cover. So let's start with the agenda for today. So I'm going to start with the problem statement. And then we're going to be discussing traditional security and continuous security and kind of do some comparisons there. And then I'll talk about an open source project that we released about 3 weeks ago. And hopefully we'll get to the demo at the end. So the problem statement of today is that in today's standards, the pace at which we're deploying applications and infrastructure is extremely fast. And there could be hundreds of deployments a day, sometimes even more. And what this situation creates is basically our infrastructure and our inventory count is continuously changing. You could have 100 instances right now, and certain condition happens, and the next hour you have 200. And what this creates is a window of things that could go wrong because you're not doing continuous assessment of your infrastructure. So it may look like this. Consider this scenario as like your traditional like pen test or vulnerability assessment or just a scan. Let's assume that you scan on a monthly basis. So you might be scanning on January 1st, and you find a bunch of bugs or a bunch of issues that you need to address. You patch them a few days later, and then you run another scan or another pen test to validate that everything was actually addressed. Now, from this point on until the next time you're going to be scanning, let's say that you're doing things like PCI DSS scans where they kind of force you to scan every month or every quarter, then the next time you're potentially going to be scanning yourself is maybe February 1st. What this creates is a window of 2 weeks that things could go wrong and you won't know about them. So in this example, consider that you have something like a firewall change that went wrong, and somebody exposed something that they shouldn't have exposed, and you end up with something like a Redis instance publicly exposed to the internet. Now, with this model, you will discover that potentially next month. And 2 weeks' time on the internet with the amount of background noise is a long time. So we want to address this model to look more like this, where we scan and we simply never stop. And the intervals between each scan could be 2 hours or 1 hour or even less than that, depending on what you want and what fits your environment. And if we do have a scenario where something like a firewall rule went wrong that exposed some assets to the public internet, you will be able to pick it up just because of the nature of the assessment that you're doing to your own infrastructure. Now, this doesn't have to be necessarily things that are publicly exposed to the internet. You can apply the same principles also internally. So with that, when I spent a few years at Paytm, our scale was pretty massive. So we had to address a problem of growth and also find the issues that we see pretty often. So we had to come up with kind of a scalable solution that will help us scale our detection capabilities in general across the company. So we went ahead and kind of thought how an architecture like that might look like. So I will start at the very bottom here. You see that there's a node called scheduler. Think of it as the starting point of the assessment. This is basically the node that is responsible for fetching your infrastructure data, such as IP addresses or DNS from your cloud providers. And this node is then setting up all these IPs and things that were collected in the database layer or like a queue for the IPs and targets to be assessed. And then you have the attack layer on the top right. And think of it as clusters of scanners that are distributed around the world. And the reason why it's important to actually put them in multiple places is to remove geographical bias when it comes to how your infrastructure looks like from different places around the world. if you do things like geographical blocking and things like that. And then our attack layer is responsible for looking at the queue, picking up any new IPs that were stored, and running certain test cases that we care about against those targets. And when an issue gets discovered, an email or a Slack hook will get dispatched to the security engineering team to take action. Now, on the left side, the deployment layer, this is where we basically come up with our test cases or things that apply to our use case. And we write these small proof of concept code or small functions that test for specific things that have high signal. So we're really looking for things that have high signal, and I'll talk about that more a bit later. And we will push that to a repo, and our infrastructure will get reprovisioned with the latest copy of the code. And any new IPs that are already in the queue will immediately get assessed against those new test cases. Now, on the bottom left, you have the intelligence sources of where you can actually get these kind of logic from. So one of the big things for us was our own bug bounty program, because we were dealing with a lot of people who are participating in bug bounty hunting in general. They have a lot of techniques and a lot of things that they use. And this was used as a source of intelligence for us. So if somebody found something on some server, we will be able to create this signature, and we will then run it against our entire infrastructure. And within an hour or two, we'll be able to know if we have that same problem elsewhere in our organization. And you can also do things like independent research if you have the resources, or simply look at other bug bounty programs and their submissions to get some ideas around what rules you could potentially write to test your infrastructure against. So we went ahead and actually built a solution, and we focused on a couple of key points. The first one was we need actionable alerts. And when you scan at scale, you want to reduce the amount of things that you will likely ignore or you will likely not prioritize. So we focused, at least at the beginning, on things that are an absolute must fix. And then we wanted to remove any vendor dependency. So we kind of started with Shodan and Census as our sources of doing port scanning and service fingerprinting. But the problem that we encountered very early on is that the data they have is pretty outdated. So for example, they might scan the internet every week. And for us, when we're doing continuous scans, we want the data of the asset as it is right now. So we had to remove them from the equation very quickly and do our own kind of fingerprinting and port scanning ourselves. And then we had to kind of have a feature where we have a safe list and an exclusion list. A safe list basically meaning that I will be able to say, I don't want certain traffic to hit certain IPs because of various reasons. And an exclusion list might be, I don't want any test cases running against any of my of this group of IPs, because maybe there is some risks that I'm willing to accept and I can address it right now. One more key thing here that is probably the most important is capturing the raw requests and responses that our attack layer generates. This is especially important if you have distributed teams in the company, and maybe your engineering team is somewhere around the world and your operations is on the other side, and an issue gets created in a different time zone than your own. And by the time you actually get to the alert, that asset that was impacted is no longer there. So you want to have a snapshot of the alert at the time that it happened, so that you can then debug and address any false positives and see why the alert was raised before it's too late. And then we needed like some kind of an alert management interface where we can reopen issues, close them, escalate them, and just take actions on them. And lastly, we needed that continuous deployment model where when we introduce a new signature, our attack layer will immediately get that data and reprovision itself, and any IPs in our queue will immediately get tested against those new test cases. So some of the pros and cons to this approach, you will definitely observe some really weird anomalies when you scan at scale. And you will discover some really short-lived issues that just simply don't exist for very long. I'll talk about some of these anomalies in a few slides. Key thing here is that you will develop some ability to detect at least a certain group of anomalies within hours or less, which is a great feature to have in general. And one interesting thing is you will definitely increase the time, you will increase your chances to win the race of the detection in general against bug bounty hunters that have their own tools, or even threat actors. When you continuously scan yourself, you have the kind of the advantage here because you have access to your DNS and your IP data. So you will likely win that race for the most part. So this is a huge win. On the downside, though, I do acknowledge that this model may not really work well if you have a static environment that doesn't really change often, or maybe you just don't have a lot of assets in general. But it really works well, and we have a lot of kind of things that we discovered over time that made us think that works really, really well when you're operating in large environments. And lastly, since you are operating and scanning continuously, then you will generate traffic on continuous basis. Your ops team may not like that idea, and I think that's the trade-off that needs to be acknowledged, although there are ways around that in general. So I want to talk about some of the weird behaviors and anomalies that I just talked about. So consider this application that is behind a load balancer served by 5 different backend servers. And let's assume that your 5th server at the bottom is vulnerable to some issue. And let's say that when you do a GET request to a /internal, some panel is going to be exposed on that particular server. Now, if you're doing a pen test, you might not know about that at all unless you do 5 different GET requests, which will eventually lead you to land on the 5th server. But when you do continuous scans, you will hit your endpoints multiple times a day. You have higher chances to actually discover these anomalies. And this is something that is very difficult to manually discover. So even when we get alerts like that, it's sometimes tricky to actually reproduce that unless we refresh multiple times, for example. So this is just one interesting case. Another interesting case is, this is more classic examples of problems that happen. If you have an AWS infrastructure and multiple people have access to it, and let's say that now with the work from home model, somebody is creating an asset that is publicly facing because they can be bothered with VPN, and they basically end up exposing some instance with their services to the public internet. And maybe it's only for an hour or two, but you have this window of something that gets exposed that you won't know about. But if you have, like, let's say a cluster that continuously takes those IPs, and you have multiple scanners, let's say in Europe and maybe Canada as well, you will be able to pick up that anomaly. And if an alert is raised by some IPs that you scan from that are not on any allow lists, you definitely know that you have an issue. So this is just another example of the things that you will likely be able to pick up. Now, I want to focus on the solution that we actually built and open sourced. So we took all the logic that we had in-house and we kind of packaged it, made it more generic, and released it. And we called this thing Project NERV, which stands for Network Exploitation Recon and Vulnerability Engine. I do want to give a shout out to Paytm that actually allowed us to open source this for the benefit of the community. So with that, I'll talk about some of the features. The key features are the REST API. In my opinion, you want to operate as much as you can automatically, but we do have a graphical user interface that you could use to do the scanning that you would do in normal vulnerability scanners through the UI. We put a lot of emphasis on high signal detections, things that we cared about and things that we feel should be tested, like certain test cases that we simply just cared about more than others. We also didn't want to do certain test cases that might produce false positives. There is a certain balance that you have to consider when it comes to which test cases you're going to run versus the true positive ratio. So you want to, you don't necessarily have to detect everything under the sun, but the ones that you detect, you want them to be true positive. So more on the features, we do support notifications in various formats and reports in different formats. You can customize the configuration of the scan in multiple ways, and I'll talk and show how a configuration might look like. It's extremely easy to deploy, and you're up and running in probably less than 3 minutes. It's all scripted, and if you want to use a Docker container, you could. If you want to install it on a VM, you could as well. And we're not there to replace your traditional scanner, so it's not an ASV replacement. If you are using things like Qualys or Nessus for PCI DSS scans or some other things, we're not an ASV, and we're not there to replace it. And you can see the link here for the GitHub project. It's also going to be at the end of the slide. So some of the detections that we do have are around these kind of categories on the left. So we do things like subdomain takeovers and misconfigured frameworks and so on. So since you will likely pull your DNS data and feed it into the system, we can do things like subdomain takeovers. I do believe that we have a dedicated BSides talk just on that topic. So I highly recommend to actually tune into that. And we're also looking at things that are somewhat misconfigured frameworks category of issues, I would call it. And this is where the core of the detection is. So Django is a great example. Django is a web framework. And if you just kind of use it by default, it comes with a built-in web server. Now, if you choose to use this built-in web server and you, for example, left the debug mode on, if you do a GET request to a Django server to a path that doesn't exist, it will happily throw a lot of information back at you with the routes that it does support. So we actually look at that level of configuration when I try to identify these anomalies. We're not blindly setting traffic for the most part. Sometimes we do, sometimes we don't. But we try to be as focused as possible on the actual service that we are encountering. Brute force, this is not new to anybody, but we can actually do brute force attacks with the list that you will provide us with, and I'll show you how it looks like. A lot of information disclosure techniques for various technologies are built into this. There is a lot of signatures for sensitive panels in general, so things that maybe shouldn't be exposed to the internet, or things that maybe you don't want certain IPs to actually reach out to if you're scanning internally, and certain best practices that we baked into the platform in general. There's more on the detection side. Feel free to check out the GitHub link for more information on the platform in general. So if you do want to get started with this, there are basically 4 steps you need to do. One is you deploy it, and I highly recommend to deploy it in multiple instances, ideally in maybe a cloud provider that you don't normally operate in, to have like a true black box kind of perspective. And then I think the only part where you need to do kind of extra work is to actually do the collection of the targets. So maybe a script that will call AWS API and gather things like publicly facing IPs or load balancers or databases and so on. We don't do content discovery at this point. It's not necessarily a bug bounty hunting tool. It's more there to integrate with your processes internally and kind of protect you from the outside or inside, depending on how you position the platform itself. And then we have the API. So you will take all the list of IPs that you gathered in DNS and you'll feed it into the API. And then lastly, you are going to act on the results. So there's an endpoint you can call to get the results as soon as something found. You don't have to wait until the end of the scan. And then you can kind of trigger your logic or your processes internally to do things like SOAR flows or a bug tracker ticket, or just do manual analysis on the finding itself. So with that, I want to show you a little bit about how the platform looks like from the graphical user interface standpoint. So there is authentication. I'm already authenticated to save some time, but the assessment basically is where you start defining your scan. This is not different than like a traditional vulnerability scanner, where you define how the metadata about the assessment itself, the targets that you want to scan. So again, everything that you see in the UI can be done in the API, and I highly recommend to focus on the API versus the UI because it's just more scalable to do that with automation. So you can define networks and domains and exclude certain IPs from certain networks if you want to exclude certain targets from your scan in general. And you can define how the configuration of the scan is going to look like. So you can toggle off and on certain behaviors. If you don't want us to run any like denial of service rules, you don't have to use that. You can define how aggressive we're going to be, which will ultimately decide which rules we're going to run and how much traffic they're going to generate. You can customize the ports that you want to look at. Maybe you want the scan to be a little bit faster, so you can focus on maybe just the first 100 ports or the first 1,000 ports. It's totally up to you. You can define the parallelism of how many groups of IPs we're actually going to scan and attack at the same time. This is kind of the bring your own dictionary part. You could do things like a sanity check against your infrastructure. If you supply, let's say, known list of users that you found internally in your company and maybe passwords that people tend to use, and you can use that as a sanity check. So when we discover let's say, a publicly facing SSH server, we will try to probe it to see if it supports passwords, and then we will take your list and try that against the server. So my suggestion is don't necessarily do like a full-blown brute force attacks against your infrastructure, more like sanity checks, so that you don't compromise on the speed of the entire process. On the schedule tab, you can actually define the schedule. How many times it's going to run? Is it just going to run once or run continuously? I recommend to run it on continuous basis. And you can define a webhook that will ultimately send a JSON payload to an endpoint of your choice. And then you will be able to act on that information, or you can just simply use the API. You could set up email settings so that we can notify you via email when something is found, or a Slack webhook, whichever way you choose is good enough. Now, once you run a scan, there's a dashboard that you can see kind of the basic data of what was found. I ran this locally on my network, so there's not a lot of interesting things here, but basically it will give you the breakdown of the severity distribution and the port distribution and the hosts that were found up and running. And you can also see like the assets and the ports that were open and services that were discovered. The interesting part, though, if you scan a lot of assets, you can see like a network view of your kind of a bird view of the assessment. So if you have large clusters around certain assets, you can zoom in on those and see which issues were found. So you can see, for example, that on the left side, I have something on my home network that has an unencrypted login form. So something that accepts passwords, but it's not served over HTTPS, as an example. You could get a list of all the vulnerabilities and see the data within them, or you can simply just export the reports and get a very basic report with all the findings and the recommendations how to fix them. Another interesting thing is you can see like a console view of the assessment as it's happening. And if you're not interested in any advanced configuration, you can simply use like the quick start to actually run the scan without worrying about any of the settings. So one thing that I mentioned was about the configuration of how a scan is kind of created. So we do accept like a JSON config with various settings here that you can customize. So for example, if you want to run a scan during business hours, but you don't want it to be aggressive, you can then call the API at a particular time of the day and just tweak it so that it's less aggressive. And maybe during the night, you want to be more aggressive. It's totally up to you, and you can customize that. You can also provide a dictionary through the API, just like I showed in the UI. These are the endpoints that we currently have in the REST API. So you can submit a scan, you can get the results. You can actually dynamically exclude certain assets and bake that into your logic. You can check if updates exist. So basically everything that you see in the UI is supported through the API. If you are interested in knowing more about the low-level details of how we execute scans when you simply provide us like with the basic quick start scan, everything is documented here in terms of how it looks like. I do want to, I know I kind of ran through these because of lack of time, but I do hope we have some time for questions. And with that, I hope you check the GitHub repo link and contribute as much as possible.
Awesome, thanks a lot. Yes, you have a question here. And that is, what do you think of the idea of some kind of integration with audit trails for network devices / servers? They elaborate a little bit.
That is actually, I think, a great, would provide great value. Anything that you could use to discover more about your infrastructure is valuable. Great,
yeah. Yep, I think that clarifies the further, the secondary question, part to that question, I should say, is around, could it be used to speed up detection, or is it just like auxiliary information?
It definitely can speed up detections, especially if you don't have anything in place right now that does a similar thing. Because of that infrastructure continuously changes, you may just face a situation where things just get exposed because of speed and because of scale. So it can help you at least build detections, if not speed them up. And this is, I think, especially true if you have a large organization.
Cool, thanks for that. So far, that's all the questions that we have. We may get some more. Overall, people are thanking you for the hard work that you've done getting that GitHub up. So yeah, I wanted to, again, thank you for doing this talk with us.
Thank you so much for
It's
having me.
great
I really enjoyed
information.
it. Thank you.
And we're about to break for